Hi, everyone. This is Mr. Neighbor, and we're talking about Chapter 16.4, dealing with prisms now. So, what is a prism? A prism is just a geometric figure of glass that refracts light. Well, refracts and reflects. It refracts the light at varying degrees, though, so you can actually see the different wavelengths of light, the visible light that is that we can see. So, it refracts the light based on wavelength. So if you recall from the electromagnetic spectrum, we go from infrared to visible light, then to ultraviolet light. We go from infrared, which is a longer wavelength, to ultraviolet, which is a shorter wavelength. Shorter wavelengths of light are reflected more. So when it goes through a prism, it's going to be reflected more than the red light. So you can see it in this image. Light goes in, it gets refracted, change direction. And if we look at it, the blue light is the one that's reflected most. The red refracted least. I think I said reflected. I meant to say refracted. So prisms allow white light to separate into the visible light spectrum, which is the rainbow, with violet being diffracted the most and red, which is the longest wavelength, being diffracted the least amount. A couple things that are kind of interesting when it comes to wavelength and diffraction. Think about the sky. The sky you normally view as blue. However, the reason why it's blue is not because the ocean's blue. Water is not blue. Water appears to be blue because of the visible light that is present. So the sun emits various degrees of visible light. One of the more common visible lights is the blue wavelength. However, the blue wavelength is short. So when it enters our atmosphere, when it goes through something, a medium, it's being changed in its direction. It's being refracted, diffracted. So as it's being changed direction, it's scattering about all across the sky. Red, that wavelength is longer. So once it hits the earth, it's pretty much going straight through, straight down, as opposed to all the blue, which is being scattered about. So as the blue is scattered, it appears that the sky is blue. And it doesn't appear a different color because the blue wavelength is being transmitted more. The sun is pumping out more blue visible light than other visible lights. So that's why it's not appearing green. But the blueness comes from the refractedness. Now think about a sunset. When the sun is setting, the sun is off to the side. So let me get a little diagram here. Here's our sun. Our Earth, though, is right here. So as the light rays come through the atmosphere, which we'll put as a dotted line. So as the light rays come through now, instead of going through directly down or directly right here where someone is at noon, they're going horizontally. They're crossing more of the atmosphere. So that means blue light, that wavelength, which is short, which is being scattered, it is being scattered to the point where other wavelengths are becoming visible. Remember, the red wavelength, which is long, doesn't really get fracted at all. It pretty much goes straight through. That's why we start to see sunsets as red or different colors of the rainbow, kind of working its way to the red spectrum, the longest wavelength, because those light rays are finally reaching us, or more so the blue that are being scattered that have so many blue are now kind of being placed somewhere else, and the other light can finally make it there. And even though it's scattered, they are more prominent because their longer wavelength is allowing them to get to us, which is right here on this part of the earth. So it's something to think about, but this is just kind of a little brief plug about why the sky is blue and how that kind of relates to prisms with the diffraction or the scattering of light.